Welcome back. We are still talking about logarithms, and today we are going to be talking about logarithms that are in base 10. As we have explained previously, the logarithm of a number simply means what is that power that you have to raise 10 to give that number. We've explained that definition in our previous videos, and we've seen that we can have logarithms in different bases. So for the next set of videos, we are going to be working exclusively in base 10 and looking for the logarithms of numbers in base 10. So for example, you can have a question that tells you to find the logarithm in base 10 of 100. So we are always going to be working in base 10 now. So at times you might see that I don't put it here, but just know we are working in base 10. So if you are told to find the logarithm in base 10 of 100, what they are simply asking you is, what is that number that I'm going to raise 10 to give me 100. We notice that 100 is the same thing as 10 times 10, or 10 raised to power 2. So if you raise 10 to the power of 2, you are going to get 100, which means that the logarithm of 100 in base 10 is 2. What if you are also told to find the logarithm of 1000 in base 10? What they are asking you is, what is that number you are going to raise 10 to give 1000? 1000 is the same thing as 10 times 10 times 10, which is the same thing as 10 raised to the power 3. So you are going to raise 10 to the power of 3 to get 1000, which means that the logarithm of 1000 in base 10 is 3. So if you notice, these numbers are giving us whole numbers because these are multiples of 10s. So it therefore means that if I'm also told to find the logarithm of 1,000,000, for example, this is 100,000, what would the answer be? The answer would be 5, because 100,000 is the same thing as 10 raised to the power 5. So when we have numbers that are full multiples of 10, not just 10, 20, 30 we're talking of, but like 100, 1000, 10,000, those numbers, 10 can easily be raised to a whole number to get those numbers, alright? So those numbers are straightforward. However, it is also possible for you to be asked to find the logarithm of a number that is not 100 or 1000, a number whose answer will not give you this whole number. So what do we do? Well, in this video, we are going to be solving some examples of numbers that aren't in multiples of 10 like the one we just solved. Now, look at this example. Imagine that we are told to find, example 1, we are told to find the logarithm of these numbers. Let's look for the logarithm of 10.25. We also look for the logarithm of 374.5, and we also look for the logarithm of 1015. Now, if you notice, for these numbers, they are not like the former ones we just did, where you can easily raise 10 to a whole number and you get them. So, how do you find the logarithm of these numbers? Mind you, we are working in base 10. Well, taking the first number as an example, we will find the logarithm of this number. Now, one thing you need to know is that the logarithm of this number always comes out in two parts. The logarithm of this number always comes out in two parts. Alright? Now, the first part, which is called the characteristic, we get it by converting this number to the standard form. Alright? The first number, which is the characteristic, we get it by converting this number to standard form. And the second part of the answer, which is called the mantissa, we get it from our logarithm tables, which I will be introducing to you shortly. So, alright, let's get the first part of the answer first of all. If you have not watched my video on standard form, or you do not know how to perform operations in standard form, converting number to standard form, please check my previous video on standard form. There's a reason we taught that before this, so that you'll be familiar with it while we're using it to solve logarithms. So 10.25, if I'm to convert this to standard form, is the same thing as 10.25 it will be the same thing as what? 1.025 times 10 raised to the power 1. Yes, so we've explained that. So if you notice, it's now in standard form. Now, the first part of our answer is the power you raise 10 to. That is the first part of our answer. After converting the question to standard form, the power of 10 is the first part of our answer. So the first part of our answer is going to start with what? 1 point. That's the first part of our answer. So we use standard form to always get this. Alright? Now, the second part of our answer, which we do not know yet, will be gotten from our logarithm tables. Now, what is logarithm tables? Well, I have a copy of logarithm tables, but you don't want to worry. I will be sending you a link to where you can download logarithm tables. Logarithm table is a prepared set of tables that already tells us the logarithms of certain numbers without having to press our calculators. It's a data sheet, alright? It's a data sheet that helps us to know the logarithm of numbers. I will be sending you a link so that we'll also learn how to use logarithm tables. Now, the quick gist about logarithm tables is that we are able to find the logarithms of any 4-digit numbers using our logarithm tables. I am going to be drawing an example of what the logarithm table looks like here, but when you are holding the soft copy, you see it's the same thing. So on your logarithm table, obviously it's a table, so we are going to be having some numbers. You have x, and then you are going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright? And then you're also going to be having another section that is called the differences. You don't need to memorize this. This is a table that you always have when you are solving. And you have differences also from 1, 2, 3 to 9. Alright? To 9. So, also for this x-axis, it starts from 10, 11, 12, down to the last 2-digit number, which is 99. Alright? Now, what this means is, in all these boxes, there are values you see in your table. You can see some 4-digit values like 3142, 7785. All of them, all these places that I'm putting decimal points, have values in your 4-figure table. Alright? So how do you use your 4-figure table? How do you use your 4-figure table to get the second part of your answer? I'm going to be using this very example to explain it. When you are calling or using a 4-figure table, if you have a number that has 4 digits, the first thing you want to do is don't bother yourself about the decimal points. Just take these digits together. So this is 1025. Now the trick I used to remember it is take the first 2 out of the 4 digits. Take the first 2 as husband and wife and look for them under the x column. So this is 10. We are going to look for 10 under the x column. And if you check your 4-figure, your logarithm tables, you will see that 10 is the first number. So what about the next number? This next number, 2, you are going to look for it under this next column. Alright? So when you are at 10, you trace to under 2. You are going to see a value here, under 2. This is 10 under 2. And what about this 5? This 5, you will get it under the differences column. So you also trace 5. Alright? When you trace to 5, you are going to get another number here. How do you get your final answer? So your final answer is gotten by adding the number you got here with the number you got under the differences column, and that's your final answer. Now I am holding my 4-figure table here. Alright, so when I check 10 under 2, mind you, you don't need to cram this. You always have a 4-figure table, and with constant practice you get better. So when I check 10 under 2, the number that is here, the number that occurs here, is actually 0.086, or rather 0086. Sorry, there's no decimal points. This is the number that is here in my table. Now I'm going to add this to, what is the number that is under 5? Remember it's 5, so we are going to check under 5. Under 5, I have 21, so I'm going to add 21. Alright, so when you add 21 to this, let me bring it down. 0086 plus 21. Alright. What are you going to have? 0, 0. Let me start from the end. 6 plus 1 is 7. 8 plus 2 is 10. That's 0, carry 1. And this is 1, 0. So you're going to have 0, 1, 0.07. This is the second part of the answer. Alright? This is the second part of the answer. So simply carry this and write this here. 0.107, and that's your final answer. So what this means is that the logarithm of 10.25 is 1.0107. Or, remember what the logarithm means. It means if you raise 10 raised to power 1.0107, you are going to get 10.25. If you have your calculators, check it. When you check it, you are going to have 10.2494 with your calculator, which is approximately equal to 10.25. So logarithm tables helps us to perform some operations without even using a calculator. We are able to find out what we can raise 10 to get any number. Let's solve another example on this. Alright, I'm going to leave this logarithm table here so that I will keep using it to explain. Alright, now for the second example, we have this example 2. We have 374.5. They told us to convert this, or rather find the logarithm of this number. Remember, logarithm, we are working in base 10. What is the first step? Remember that your answer will always be in two parts. How do you get the first part? By converting this to standard form. Alright? Now, at this point I'm going to teach you a shortcut. It's either you take your time converting to standard form like this. For example, what is going to happen in standard form? If I convert this, remember to put a number in standard form, you have to put the decimal points between the first two digits. Alright? So if I move this back twice, 1, 2, that is 3.745 times 10 raised to power. How many times did I move? 2 times. And then I will take this power of 10. This is all I need from this whole operation. It's only the power I need. That's the first part of my answer. 2 points. Alright? So you see, I've gotten the first part of my answer. But if you don't want to be writing all this long process, it's easy. For you to get the first part of your answer, check if the decimal point is between the first 2 digits. If it is between the first 2 digits, that means you don't need to move it. Or you move this 0 times. Right? So your answer will start with 0 points. But like in this example, if you check, it is not in between the first 2 digits. So how many times do you need to move it backwards? If you are moving it backwards, how many times do you need to move it to get there? If you move the decimal points 1, 2, you need to move it 2 times. Just know that the first part of your answer will start with 2 points. It's as simple as that. Alright? So it therefore means that, for example, C, for example, the first part of our answer, since this is 1015, the decimal point is basically here, 0.0, right? So if I'm going to find the first part of my answer, I need to move the decimal point to be between the first 2 digits. How many times do I need to move it? 1, 2, 3. So that means the first part of my answer will be 3 points. That's a simple secret. Alright? So let us proceed with this example 2. We'll find the first part of our answer as 2 points. Alright? Now, the next part is going to be gotten from our logarithm table. Now, don't forget how to read your logarithm tables. You have 4 digits. When it's time to read the logarithm table, forget about this decimal point. Now we have 4 digits, right? Now these 4 digits, this is 3745. Take the first 2 as husband and wife, as I would say. Call it together as 1. That is 37. So this is read as 37 under 4 difference 5. So you will come to this first column, this X column. This is where you are going to look for your 37. Alright? So you keep going down 10, 11, 12 until you see 37. Alright? Then when you are in 37, what is the next digit? 4. So you are going to trace 37 under 4. So the number that comes here, 37 under 4. You write it down first of all. So 37 under 4, if you check your logarithms table, as I am checking my logarithms table, when you trace that line, when you start from 37 and you trace, this is where I have 37. When I trace under 4, I have 5729. So I'm going to write that somewhere first. 5729. Alright? Difference 5. That means I'm going to go under the difference column. Where 5 is, I'm going to trace it down where it meets here. Alright? So I will keep moving to the difference column and go for difference 5. So when I check my difference column, difference 5, the number that is here in the table is 6. So I'm going to add 6 to this 5729, and that will give me 5735. Alright? So this is the second part of my answer. And all I need to do is to add it here. 5735. So the final answer is 2.5735. So what this means is that if I raise 10 to the power of 2.5735, I will get this number, something approximately equal to it. Press it with your calculator. So when I press my calculator, 10 raised to the power 2.5735 gave me 374.54, which is approximately equal to what the question gave us. So you see that logarithms are an approximate way of getting the power to which you raise 10 to get those numbers. Alright? So let us do this last example, example C. The aim of these examples is to familiarize yourself with the use of logarithm tables. So the example C, where we are told to find the logarithm of 1015, we've explained already that your answer must be in two parts. And the first part is gotten with standard form, right? So this 1015, if you notice there was no decimal point, but you are to know that 1015 is the same thing as 1015.0. So you can always add a decimal point after the last digit in case your question doesn't give you a decimal point. Alright? So how do you convert it to standard form? We are going to move back. We want our decimal point to be here, between the first two digits. That is how you convert a number to standard form. So for you to put it here, how many times do you need to move it from the original position? 1, 2, 3. I moved it 3 times, which means the first part of my answer is 3 points. It's pretty easy, right? Now, the second part of my answer is gotten from the logarithms table. Alright? So when I go to the logarithms table, 1015 is what I'm looking for. Alright? 1015. And as I've said, we pick the first two together to be what? 10. So this is the same thing as 10 under 1 difference 5. 10 under 1 difference 5. So this is 10. When you move under 1, you get the number here. This is 1. Alright? This is 10 under 1. So when you check your logarithm table, 10 under 1 is going to give you 0043. But we are not done. We have difference 5 as well. And difference 5 for that column gives me what? 21. So I'm going to add 21. Alright? This is difference 5. 10 under 1 difference 5. Alright? So what does this give me? 3 plus 1 is 4. 4 plus 2 is 6. So I'm going to have 0064 as my answer. Alright? So the final answer is 3.0064. Meaning that if I raise 10 to 3.0064, I should get 1015. And truly, when you press it in the calculator, 10 raised to the power 3.0064 is going to give you 1014.85. So you see that in logarithms, you can actually use your calculator to confirm if what you got actually is the answer. Alright? So let me give you some examples you can try. Mind you, as you keep using the logarithm table, you will get better at it. Alright? Now, see if you can solve these examples. Look for the logarithm, obviously in base 10 of these numbers. Now, look for the logarithm of 72.51 and also look for the logarithm of 37.42. Alright? So, thank you very much for staying to this video and see you in the next class.